Today, let's take a look at some of the things I've had come in the mail, but I haven't had time to really work with. So let's just kind of go through a few that will be coming up. I've been wanting to work with ST micro boards, so I bought a variety of these. Well, that's just not going to work. Let's get a knife. And I'll leave links to all of these things down below. Here we go. This is a nice small board, STM32. That's definitely what I've been wanting to work with. This one's really well sealed up. See if we can do this without leaving a scar. All right. Very tiny board. That little chip may be perfect for some of the things I want to do with some I2S and sensors and things on the sorting robot. I picked up another one here that might be more suitable for experimentation type work. Again, they all come with headers, a little bent up. Let's see, what do we have? Yeah, same chip, STM32. It's just that it's on a nice dev board. And to make it even simpler, I bought a kit that included the programmer and everything else. So this little programmer takes all the guesswork out of it, and this came with 2 boards. So I now have 4 of varying sizes, and I think that will make it easy to go through and do some development with the STM32. These are for 2 different types of 2 different levels of the 32, different versions of them, but generally the same on the cores. So looking forward to working with that. Here we have the tiny board. That's in this case, SMAKN. It's an standard ARM32, STM F03, FP46. The slightly larger one is, again, a 46 P46 or 46 P6, sorry, and again the same vendor. These are $8 each. Yeah, $8 each delivered from Amazon. And again, another one. This is a slightly different one. It's often called the Blue Pill, but the nice thing is it does come with 2 boards and the programmer. And that was for about $19 delivered. So again, you're paying about $8 for a few dollars for each of the boards, and then a few dollars for the ST-Link V2. So it's going to be nice to have the proper programmer to take all the guesswork out. Next up, we have the Monoprice USB extension cable. And this is a pair of connectors. Let's go ahead and open that up. I have a special use case. I need to run USB for maybe 50 feet. So you can use a Cat5 cable. This is not Ethernet. So this is not, you're not going to plug this into your network switch. This is just going to go use an Ethernet cable, Cat5, and you get USB that you plug into your host, like your PC, and then on the other end you can plug in a keyboard or mouse. And in fact, I have the very need of controlling a over USB, running a hardwired mouse to a security monitor NVR. So the monitors are around the room here, but the location of the network video recorder is not conducive. So I'll come back and I'll show that, and maybe today. Here we have the Monoprice USB extender, and it can use a Cat5 cable up to 150 feet. So we'll try that out. I've been a little skeptical of this because the USB specs do limit that run, but maybe we can pull it off with this. There's a lot of options out there for this sort of thing, but this seemed very reasonable. Some of the devices are very expensive out there, going into the $50 range, some going into the more like $100 range, and I thought, $15, let's try it out, see how it works. Next up, we have speakers from Adafruit, and as well as, let's look at these. Okay. No markings, but it looks like about the same speakers as from Adafruit. I wanted a couple options here to build a couple devices. And, ooh, tiny JST connectors. I have a kit. Boy, I'm not sure what the size is on those. 1 mil centers, maybe? You're going to have to check that out. And no markings, so don't know what the wattage is, but probably exactly the same as on the Adafruit. I think these were listed at, here we go, 3 watts, 4 ohms. Now, to drive those, I have picked up, also from Adafruit, links will be below, this little Raspberry Pi speaker header, 3 watts, 4 ohms. So this should drive the the speakers, I think, can plug right in here, and it can drive those. And what else do we have down here on this line? So to do all this, it's I was wanting to work with I2S, and especially on the Raspberry Pi. And in fact, I picked up a Pi Zero for $5 at Micro Center. I have Pi Zero W, that is. So wanted to work with that, with I2S audio, as well as with the ESP32. And I thought I can find some libraries on the for ESP32. Here's another I2S board from Adafruit. They've got a lot of neat stuff over there dealing with I2S, along with libraries to make it easier to use. And I'm not planning to just use it for, say, pre-recorded audio, MP3 files that get triggered or something. No, this is a tiny, I'm not even going to be able to get this camera to focus on it very closely. This is a very tiny I2S microphone. It's a MEMS microphone, and I picked up a couple of these just because I wanted some options to see, what would work best. Let's get this one out too. So just a couple of different options to see, because these are actually different microphones. These are different models of MEMS microphones. I wanted to try out a couple, just kind of see what worked best, which ones had better libraries and things like that. Here's the speakers from CQ Robot, and these are listed as 8 ohms. That'll be interesting to see if they're really any different from these from Adafruit that are listed as 4 ohms. Oh, let's look at the pricing on that. So $8 for the CQ Robot, twice that almost, $14.50 for the Adafruit version. And then here's the MEMS microphone. Looks like some of these may be limited shipping capabilities or something. $10 for that, $8 for this other one. And these are, of course, on breakout boards, so you're paying something for that. There's, voltage regulators and filter capacitors on it. And then here's the I2S 3-watt stereo speaker, what they call a bonnet, and that's $13.50. So this cost a little bit to do this experiment, but it's with multiple products. And it's something I've wanted to work with for a while, but just hadn't had the stuff around. And, of course, I have space now. Okay, I'm hoping this is going to be a fun one to work with and not a nightmare of things that don't work out. This is the Coral Accelerator. So this is the Google Coral, and looks... Skookum? Oh, that's nice. You get to use a plug, and it's a USB-C. I was afraid I was going to have to plug that straight into a PC like one of the others, like the Intel one. So it comes with a little USB-C connector, so I can work with this on a higher powered desktop Linux machine, and then and create training models. Then I can plug this into like a Raspberry Pi or an Odroid and use it there. And I'm going to use this for optical recognition and motion control. So I'm hoping to be able to use a small camera on the end of a robotic arm, and have the arm be able to see things and center itself over a given target. That's going to be complicated. It's going to take a while. So there will be more on this as winter progresses and I'm inside all the time. And I got this from Mouser, just because they were the ones that really had it in stock. I looked at several suppliers, and the stock was pretty low about 2 months ago. And that's how long a lot of this stuff has been sitting around. And it's literally been sitting in exactly that spot on that bench most of that time. They do have a larger dev board, but I think this is the right one. Yeah, on the Coral dev board, it is a fair bit more expensive. So, and it wasn't quite what I needed. I wanted to be able to control a lot of devices that through Raspberry Pi libraries that are kind of specialized. So I figured, well, let's go with the Coral USB extension and see how this works out. So more on this as winter progresses, and I am indoors all the time. Next up, Pololu has delivered a, there we go, stepper motor driver. Oh, and it is very well packed. It was not going to move around on us. This is the Kick T249 USB multi-interface stepper motor controller. Let's take a quick look at this. Yes, there is a project in mind. Enlarge your brain. Robotics and electronics. It's smaller than I expected, although they do show the dimensions on their site. It's a fairly little board, but it can handle up to, it's a stepper motor controller, so bipolar, 2 coils, handles up to 47 volts at up to 4 or 4.5 amps. Quite a bit, but it has a lot of really neat options on it. Unlike a traditional controller where, gosh, do I have one of those around? This is a typical micro stepping driver. Actually, this is a nicer one that I've been using in the past, and I think this was a little bit more expensive, but it all works the same. You've got your coil in down here and your power. Then up here you control it by having to give it a signal, a high or low for a direction, like if you want to clockwise, counterclockwise, and then you have to pulse it, and you send a pulse train, and then this switches the coils so that it moves the stepper in the direction at the speed you would like. There's a lot of processing you have to do on the back end, though, to send these signals in. This little guy does pretty much all that work. It can be controlled by USB with a USB micro, or better yet, so the Raspberry Pi can communicate with this thing over at least SPI, if not I2C. I can't remember exactly. We'll look at the specs on that. And it can say, hey, at your current position, set that to 0. Now move 500 pulses or 2,000 pulses up, and do it at this speed, and do it with this acceleration. So it can accelerate up to the speed you tell it, and then on its stepping, and then slow down as it gets to the target step count. That's fantastic. I've seen boards that do that in the past, but they tend to be They tend to be they were very expensive. They were larger. They were more like this in size, and they were like $300, $399, and so I never really took any interest in them. So this could be really cool. Definitely going to work with this very soon. This will probably be the very next thing I work with. So here it is. They have a variety of these. Here we go. Yes, it supports USB to USB, TTL serial, I2C, not SCI. Okay, not SPI. It does have I2C. It can handle quadrature encoders. It can do all sorts of things. It even has an automatic zeroing mode, if I recall. And you can say, hey, go to 0, and it will, in this direction at this speed, it will go in that direction until it hits a limit switch that can be connected to it. So lots of cool stuff for this. And here's a little lineup of the family. I have the TIC 249. So peak current is 4.5 amps. 1.8 is the continuous. But that's, at 24 volts, it's still a pretty hefty servo. I can use some pretty good torque with that. There's a higher end model that's higher end in some ways, got more steps, more current. It is a little more money. This one has the automatic gain control right here, and I'm trying to remember the description of it, but it sounded very interesting, so I decided to go with that. There are much cheaper models. They don't necessarily have all of these capabilities that I'm looking for, but this TIC T500 might be the thing that I would go with in the future because it would support 24 volts, enough current, because my servos usually aren't running at very high current loads, and it's $20. And that is way less than the other boards that I've seen that have these capabilities. Next up is a crowd supply from Unexpected Maker. He has a nice YouTube channel. I've been watching him for a while. I've watched some of his products get created. And this is called the Tiny Pico. I subscribe to the 2-pack. And it's a nice little, I do mean little board. It's an ESP32 based device. Here we go. With headers. Oh, that's the breakout. Here we go. Here's the Tiny Pico. It's very small. Yeah, gonna have a hard time getting good focus on how neat this little thing is. It has built-in USB. It has some low power modes that he's created, if I'm remembering everything correctly. Actually, and a 3D printed little, at least it looks that, antenna protector right there to keep it from getting bent and shipping. Anyway, very neat. He's got a lot of information about it. Here's his crowd supply. It was very successful, $40,000. So here's the one I signed up for, and it can run MicroPython and has lots of neat stuff. So check out his YouTube channel below, and the Tiny Pico. It's a really interesting little board, and I think you might find his work very interesting. Last up, I want to thank Ben at Applied Science for sending the stickers for the Patreon level I upgraded to recently. I've been watching Applied Science for a few years and been a Patreon supporter since he started that, and it is an interesting channel. Ben's work is well beyond that one might see for most channels. He just does all sorts of things. He does a little bit with electronics, but it is a tremendous amount of it is chemistry and other related. So glass, he built an electroluminescent glass panel display. He did some years back. What was one of them? It was very weird. Oh, he fried bananas in a vacuum. So that was really interesting to see how the chemistry worked out and some of those things. So Ben does a lot of really interesting stuff. He does not generate videos like every week. That's not his thing. His stuff many of these will take months and months of research in order to pull it off. So he may have several things going at once in order to create a video even on a monthly basis. So Ben's work is really cool. You've got to check that out. So welcome to the first mailbag at the new place. I've been working on lots of projects, trying to get this space put together. This is the new bench in the center that I showed in the intro video of the lab, and it provides me with the ability to have another thing going on over here and still be able to do other short-term efforts.